Designing a buoyancy compensator device, also known as a BCD, requires the fashion knowledge of a clothing designer and the expertise of a diving design engineer.
The D-ring on the front to the cummerbund right here.
A computer program draws a pattern of BCD pieces on a marker. Workers match coated fabric to the marker and cut out the pieces. A cutter cuts the coated fabric into various shapes from the pattern. The program minimizes wasted material since it is one of the most expensive components in the BCD. A die press goes into a special fabric welder that fuses the front and back halves of the BCD bladder together using radio frequency or RF energy. The RF energy, similar to a microwave, bonds the layers of the coated fabric. The bond is as strong as the fabric itself. The cut pieces lie on top of the die. Workers place pieces called ligaments inside the bladder on some BCD styles. Ligaments make the BCD expand flat instead of out like a beach ball. Workers insert the die and coated fabric into the welder where a similar die from above matches the welding points. There is very little heat in the fusing process. A patch on the back of all attachment points keeps them from leaking. The same process that fuses the bladder joins the patch to the jacket. Low-pressure inflators and dump valves attach to the bladder with these fittings. An RF energy press fuses the pieces to the jacket and to each other to complete the seal. Most conventional BCDs use Velcro heavily. A cold web cutting machine cuts Velcro to appropriate lengths. A webbing or plastic strip called a channel strengthens the BCD at all attachment points, such as those for the waistband or webbing straps. A patch goes on the reverse side to keep air from leaking out of the BCD. Workers use heavy-duty sewing machines to stitch Velcro and other materials to the BCD. This 20-head embroidery machine sews logos onto pieces of BCD material. The computer that drives the embroidery machine controls the various colors and designs applied to each piece of fabric. After embroidery, workers sew the separate pieces to the BCD. Workers secure the pack frame directly to the BCD body through the back pad using a special heavy-duty sewing machine. Workers assemble and attach various straps to the BCD. The low-pressure inflator releases or adds air to the BCD. The low-pressure inflator style being assembled serves as a combination alternate air source, second stage. Assembly requires the same precision as a regulator. Before connecting a low-pressure inflator to a BCD, workers test it to ensure proper function. The finishing process includes the attachment of the alternate air source, low-pressure inflator, and the dump valve to the BCD. The final test for a BCD involves filling it to twice its operating pressure, returning it to working pressure, and allowing it to sit full of air for 4 hours. The manufacturer destroys any jacket that leaks and isn't repairable. After the BCD passes all inspections, it is shipped out with appropriate user instructions and care considerations.